Hey guys, so today we are going to be still comparing all of our functions, and today we're going to be graphing and learning about their transformations. Well, relearning, because again, we've done all of this now. But today is actually going to be a little bit longer. We have like 4 pages to get through, so let's go ahead and jump right on in. So for linear functions, how we graph, we always start with our y-intercept. But we have to make sure that we're in standard form, which we are. So when we start at our y-intercept, we start at our b. So we start here, and then we have our slope of -2 over 1. Okay? So that means we're going to go down 2 to the right 1, 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 and so on and so forth. And then once you reach as far down as you can go, you need to do the opposite. So we went down 2, so now we're going to go up 2. We went to the right 1, so now we're going to go to the left 1. And then we just connect all of our dots. And don't forget to put your arrows. Okay? Alright. For our next one, when we are not in standard form, because as you can see, 9y minus 5x equals 27, we need to put it in standard form. So we need to solve for y. Okay, so we're going to start by adding 5x to both sides. And we get 9y equals 5x plus 27. Okay, and then we still need to get y by itself. And so we need to divide everything by 9. So we're going to get y equals, because our 9's cancel out, 5 divided by 9 does not simplify, x, and then 27 divided by 9 will give us 3. And so now we can graph that, because we're going to start at 3, and we're going to go up 5 to the right 9. 6, 7, 8, 9. And then we're going to go down 5 to the right 9. Okay? And then we connect our dots. Alrighty. And so that's how we graph linear functions. Now we're going to go on to quadratics. Okay? So for quadratics, our first one is in vertex form. So remember, with vertex form, it automatically gives us our vertex, because this is our h and our k. But remember, h lies. So our actual vertex, it tells us 3 is going to be -3, comma, -1. So we can go ahead and graph that, -3, -1. And then we need to make our table of values, okay? So remember, -3, -1 needs to be in the middle. And then we can go -4, -5, -2, -1. Okay? And then our calculator, we have 2 parentheses, x plus 3 squared minus 1. Again, my calculator is different, so I don't want to confuse you guys. Alright, so then we have our table. And so -1 is 7, and then -2 is 1, -3 is -1, and so -4 should be 1, -5 should be 7, because remember symmetry. Okay, alrighty. So now we can graph those points. -2, +1, -4, +1, -1, +7, -5, +7. And we're done with that one, okay? For number 4, this one is in standard form. So if you remember, we need to find our axis of symmetry using the -b divided by 2a. And then we need to substitute it back into our equation, okay? So for -b, remember this is our a, our b, and our c. Okay, so we're going to have negative 10 divided by 2 times negative 1. Negative 10 divided by negative 2 is going to give me 5. So then we're going to make our table of values with 5 in the middle, 4, 3, 6, 7. And then if you don't want to substitute it into your equation, I don't blame you whatsoever, you can just put it into your calculator. Let's make sure I typed that in correctly. There we go. And then we're going to scroll all the way to 5, and it tells us 4. And make sure that your numbers after that repeat. See how that 3 and the 0? So perfect. So 4s, 3s, 0s. Okay. So then we can go ahead and graph that. So 5, 4, 6, 3, 4, 3, and then 7, 0, 3, 0. Awesome. Okay. And hey, look, we're done with the first page. 1 down, 3 to go. All right. So then for our next page, we are going to be graphing exponential functions, okay? So these look a little bit more different, but that's okay, because I want you guys to remember our asymptote. All right, that's going to be the first thing that we need to graph. And our asymptote is whatever is added or subtracted from our function. So because we have a positive 2 here, that means our asymptote is going to be 2. Okay, and then we're just going to type our equation into our calculator and make a table of values. Okay, so we're going to have 3 times 2, x minus 2, and then plus 2. Alrighty, so for this, I would say start at 0 so that you have your y-intercept. So that's going to be 0, and then 2.75, and then 1 is 3.5. Sorry guys, forgot to actually show you my table. And then 2, 5, and then 3, 8. And that's pretty much as far as we're going to get. Okay, you could go into the negatives, but those get harder to graph because there's more decimals. So for 0, 2.75 is going to be about right here. 1, 3.5, 2, 5, and then 3, 8. And remember, we connect our dots towards this side and then get really, really close to our line on the other side. Okay, and that's our exponential graph. And then we're going to do the exact same thing on the next side. Our asymptote is going to be this negative 2. We're going to make our table of values. We're going to type it into our calculator. And for this one, it's actually kind of hard because we only get 3 points that are relatively easy to graph. But that can also make it easier. So negative 1, 10, 0, 1, and then 1, negative 1.25. Okay. Again, you just type the equation into your calculator and go to your table of values. Alrighty. So now we're going to talk about our transformations. Okay. So transformations describe the change in a function from its parent function or another function. Alrighty. So for our linear function, our a is our slope. And our k is our y-intercept. I do not know why they put a and k here. Really and truly, it should be y equals mx plus b. But it's okay. They're trying to make it look like the other ones that we've just literally never used before. Okay. All right. And then for quadratic For this one, our vertex is going to be that h and k. And then here, our k tells us our asymptote. Okay, so those are the things that we can grab immediately from our function. Okay, now we're going to look at A. A is going to tell us a whole bunch of stuff. You ready? Alrighty. So, A tells us reflection. If the A is negative, it reflects the graph over the x-axis. And we've talked about all of this during our quadratics unit, okay? And then our A also tells us if we have a shrink or compress. So if our A is greater than 1, and remember the sign does not affect this transformation, this makes the graph flat or compressed. Okay? The way that I think about this is when A is less than 1, I said greater than. When A is less than 1, it's compressed. I like to think of it like a ball of Play-Doh. When it's in a ball and then you flatten it, you just press on it, it gets really, really flat, okay? So the closer to 0, the more wide or compressed it is. Okay? We could also have a stretch, and this is when A is greater than 1. And again, the sign does not affect this transformation. This makes the graph more narrow or stretched. Okay, so for stretch, I think of it like a piece of chewing gum that you take out of your mouth and put it in between your fingers, and then you just stretch it out, and it gets really, really thin. So the further from 0, the more narrow or stretched it is. Okay. Alright. Next we have K. We have H. Okay. And this is the horizontal shift. Or the left or right movement of the graph. Since it's dealing with our x's, the direction is going to be opposite of what it looks like. Okay, so x minus h will move right, and x plus h will move left. Notice that our linear function does not have this transformation. Does not have an h. Okay? Alright, and then finally, k is the vertical shift. This is our up or down movement of our graph. Okay? And hey, look, we just finished another page. That's exciting. So now, using what we just learned, we are going to list our functions in order from the widest to the most narrow. Okay? So remember, our wide functions are going to be the numbers that are less than 1. Okay? So, to be less than 1, it has to be a fraction. Alrighty? So you want the smallest fraction first. Okay? Because it needs to be closer to 0. So, we have the fractions of 1/2, which will give us 0.5, and 1/7, which is 0.14. So our first one is going to be j of x. Sorry guys, I forgot to say, I'm looking at the a values. That was my bad. Okay, we're looking at our a values because it's asking about shrink or stretch. And it wants the shrink ones to go first. Okay? And so we did the 1/7. Now we have the 1/2 because that's a fraction. And then we want the next largest number, which is going to be 2. So that's going to be f of x. And then our last one is 4, h of x. Because remember, it does not matter if it's negative. We just want the number. Okay? Alrighty, let's take a look at number 8. Choose the best statement comparing the graphs of the function below. Alright, so it says the graph of g of x, which is this one, is shifted up 6 units. Okay, so let's just pause right there. First of all, do you see a 6 in here? Because I don't. I do not see a 6. So that is very likely that it's not it. Another way to tell is that this number right here, this is what tells us up or down. And if it went up, this would be a positive. And it would also be a 6. So we know it's not going to be A. And then right would be this number, but it would have to be opposite. So we don't like that one. Okay? Alrighty. Oh, wait a second. Oh, I see. Okay. So I get where they got the 6 from. Okay. So, because it's from the graph of f of x. So this one, think of this like the point 0, 4. Okay? And here we are at the point -5, -2. Because nothing is added or subtracted. That's how I got the 0. And then the 4 right there. And then here is -5 because opposite and -2. So we go from, since it says up 6 units, that's our y, okay? From 4 to -2, we go, depending on which one goes first, that's where they get the 6 from, okay? But still, it's not moved right 5, it's moved left 5, okay? All right, so we actually need to find something that just says left 5. Up and down? Well, no. Okay, so the graph of g of x is shifted up 5 units and down 2 units. So no, because we can't be shifted up and down at the same time. The graph of g of x is shifted right. Well, it's not shifted right, it's shifted left. Okay? And then the graph of g of x is shifted left 5 units. There we go, left. And down 6 units. 4 to -2 is down 6. So that's why it's D. That is a very confusing problem. You have to read it very carefully. Luckily for you guys, y'all don't have to take the milestone, but this would have been a huge milestone question. Well, I mean, the class of 2020 does not have to take the milestone. I'm planning on using these videos after 2020, but yeah, this would have been a huge milestone question. All right. So for number 9, given the function y equals 2x squared plus 5, write an equation whose graph is reflected, shifted to the left 2 units, and shifted up 4 units. So the very first thing, just look for reflected, okay? When it's reflected, that means that our a value, and what's our a value? Is 2. The sign is going to change. So that means that this needs to be a -2. So I'm going to write y equals -2x squared, okay? And it's going to be shifted to the left 2 units. Okay? So I need to scratch this out. So y equals -2. And then because we're moving to the left 2 units, I'm going to have x plus 2 squared, because remember left, sign changes, and then up 4 units. So that's going to be plus 4. So which one looks like that? Miss Johnson, there was already a 5 there, so shouldn't you add 4 and 5? Why, yes, class, you are absolutely right. We do need to add 4 and 5 to give us 9, which is why our answer is C. You guys are so smart. Man, I love the participation in this class. Y'all are so great. I promise I'm not completely insane most days. Alrighty. And so now we have a table of values for f of x and g of x. Which statement compares our graphs of f of x and g of x over our intervals 0 to 5? So that's just our x values 0 to 5. Okay? So the graph of f of x always exceeds the graph of g of x over our interval. So that means that at every single point, f of x is greater than g of x. Okay? So f of x is greater. Yep. 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 Nope. Okay? Because at our very last point, the 29 is greater. So that's not true. All right? The graph of g of x always exceeds the graph of f of x. Well, we just showed that f of x was greater except for that one point. The graph of g of x exceeds the graph of f of x over the interval 0 to 4. And the graphs intersect at a point between 4 and 5, and then the graph of f of x exceeds the graph of g of x. Well, let's just start with the first part. G of x exceeds the graph of f of x from 0 to 4. Well, that's not true, okay? And then the way that graphs change which one exceeds is that they do have to intersect. So this part is true, but everything else is wrong, okay? So then the graph of f of x exceeds the graph of g of x over interval 0 to 4. Yep, 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 yep. Cool. So I like that. The graphs intersect at a point. That's true. And then g of x exceeds. Perfect. That's exactly what happened. That is a wordy question. This is also a milestone question. Alrighty. And then finally, which statement is true about the graph of exponential growth functions? Notice it says growth. Okay. The graphs of exponential functions never exceed the graphs of linear and quadratic functions. Well, that's not true because they will always exceed at some point. The graphs of exponential functions always exceed the graphs of linear and quadratic functions. Well, not always, okay? Okay, the always is the tricky number because you can have points on exponential functions that are lower than points on quadratic and linear functions. The graph of exponential functions eventually exceed the graphs of linear and quadratic functions. Well, yeah, absolutely. Let's make sure the last one. The graphs of exponential functions eventually exceed the graphs of linear functions, but not quadratics. Well, that's not true. So it's definitely got to be C. Because, remember, our exponential functions, they start out like this, but then they get really, really steep in their slopes. Linear functions can be steep, okay? But exponential functions will always eventually exceed. Always eventually exceed, okay? And quadratics. Because remember, with these two graphs, we're adding to get to the next number. With exponentials, we multiply. And multiplying will always get you more money faster. Okay, that's the best way to think about it. Alrighty, I think we are on our very last page. That is super exciting. Alrighty. So now we're going to use this graph and this table to compare. Now, which function has the higher y-intercept? For our graph, our y-intercept, y-axis is 6. And for our table, it's 1. Okay? So definitely here we go, h of x versus j of x. H of x has the higher y-intercept. Now, which graph has a smaller rate of change over our interval 2 to 4? I'm going to do the cheat way for my graph. So I'm going to go up 1, 2, 3, 4, plus 4, plus 2. So our graph has a slope of 2, because remember 4 over 2 and then 2 to 4. This is going to be plus 2, and then this is going to be plus 12. Yep, 12 divided by 2 will give me 6. So this time, up smaller. So this is also going to be h of x. And then finally, which graph is higher on the interval 2 to 3? Okay, so 2 to 3 is this interval, and then 2 to 3 is this interval. So so the point here is 2, 2. Whoops, I got all slanty. Sorry, guys. So 2, 2, 2, 4. Okay, and then 3, 3, 3, 8. So because these two numbers are higher, j of x is the higher interval. Alrighty, cool. So then, the very last thing is that we are given a graph and it wants us to graph 2 times it. Okay, so what this means is that we need to multiply our y values by 2. Okay, so we're just going to take each y value that we can and multiply it by 2. Alright, so I'm going to start here. So this is a y value of 2. 2 times 2 gives me 4. Okay, then I'm going to find another pretty point. 3 times 0, well, 0 times 2 will still give me 0. Negative 2 times 2 will give me negative 4. Negative 4 times 2 will give me negative 8. Let me see if there's another pretty point. 4 times 2 will give me 8. Lovely. And so that is how you graph 2 times a function. You're just going to multiply all of your y values. Alrighty. Now for this one, our next one, it says graph g of x plus 4. So if you recall, when it's inside the parentheses with x, this means that we need to move left or right. And because it's plus, we need to move left 4. So all of our points, we're going to move left 4. So I have this point here, move it left 4. 1, 2, 3, 4. This point, 1, 2, 3, 4. This point, 1, 2, 3, 4. Let's see. Find another pretty point if you can. Here we go. 1, 2, 3, 4. 1, 2, 3, 4. And I do believe that's all of our pretty points. Okay. You will learn the actual term for this in geometry. It is called translation, where you just move things up, down, left, or right. Okay? And it's just where you take your shape and move all of it. And congrats, guys, we are done with comparing. Yay, I'm sorry for the super long video, but I think it was worth it. Good job, guys.